Welcome to Spring LIB.
In this question, it is saying that first refer the previous problem and after it some do correction. So first I will taking the previous problem, that is question number 50, in which the data is given, that is there is a hard surface given, and on this hard surface there are two blocks given having mass, that is first block having mass m1 and second block having mass, that is m2. Now both blocks are connected by spring whose spring constant is given, that is k. So now in the question, in this problem, it is saying that here change the impulse and take a constant force. So that means in the previous problem impulse is given here, which is acting at m2 block. So now we have to do a correction, that is we have take a constant force such that each of block is trying to pulled by this force. So that means the direction of force will be, I can say that for first block the force direction will be towards left, and for second block the force direction will be, that is towards right. So you can now see in the figure that these force are trying to pull the both blocks. So this data is given, and now in the question it is saying that find the maximum elongation of spring. So that will suffer. So let's start answering this question. And in the question also saying that here we have to find the maximum elongation of spring that will suffer, and the distance moved by two block in this process. So now let's start answering this question. So here I can say that let assume x1 x2 is a extensions of block first block and second block respectively. First block means having mass m1 and second block that means having mass m2. So here I had considered that the extensions for first block is x1 and for second block extension is, that is x2. So now next step is, I can say that the total work done by the force on the block will be that is equal to fx1 plus fx2. So I can say that this is equation number 1. Now next step is increase in the potential energy of spring will be written as, that is that will be equal to half multiplied by spring constant, that is k, multiplied by x1 plus x2 whole square. So I can say that this is equation number 2. Now next step is, here I am using the law, that is law of conservation of energy. So according to this law, the equation number 1 and equation number 2 will become equal. So I can say that means the total work done by force on the block will be equal to increase in the potential energy of spring. So here I can say that equation number 1 is become equal to equation number 2. Now after putting the data here, I will get the result, that is x1 plus x2 is equal to 2f over k. So this is a equation number 3. Now as you see in the figure, there is a no external force, sorry, yes, there is net external force is 0, because you can see that they are acting in opposite direction. So net external force will be, I can say that will become 0. So that means I can say that the center of mass does not shift. So by using the concept of center of mass, the next step will be written as, that is m1 x1 is equal to m2 x2. So this is a equation number 4. Now by using this equation number 4, put the value of x2 in equation number 3. So I can say that use equation number 4 and put the value of x2 in equation number 3. So result will be written as, that is x1 plus x2 will be, I can say that by equation number 4, x2 will be, that is m1 x1 divided by m2 is equal to 2f divided by k. So now simplify it, then I will get the x1, value of x1, that is equal to 2f m2 divided by k multiplied by parenthesis of m1 plus m2. So this is the extension for first block. Now similarly the x2 will be written as, by using the equation number 3, I can say that x2 will be, that is 2f multiplied by m1 divided by k times of parenthesis of m1 plus m2. So this is the extension for second block having mass, that is m2. So I can say that I had get the answer, as in the question asking that we have to find the maximum extension in the both blocks. So I had solved the question completely, that is the for first block extension is, that is 2f m2 divided by k times of m1 plus m2, and for second block the extension is, that is x2, that is equal to f2f m1 divided by k times of parenthesis of m1 plus m2. Hence I had solved the question. Thank you.